Yeah, I want to echo what a lot of the previous presenters said, and apologies for having to call in virtually. I was really looking forward to meeting a lot of you in person. What I'm going to show you today is some output from some NATO research that was conducted over the last 3 to 5 years. So I want to definitely acknowledge my co-author, Mr. Harry Byers. Unfortunately, he was my software engineer. I'm more of a systems engineer, but I'm from the U.S. Air Force Research Lab. I'm at Wright-Patterson Air Force Base in Dayton, Ohio. So thanks to Majid and also to Mitch Ingham at the AIAA level, where I first kind of got introduced to JPL and some of the things that their good work that they're doing with OML. So the model validation ontologies I'm going to show you today are it's really an effort that we're looking at to figure out how to connect our modeling and simulation predictive tools to the government reference architectures you would see implemented for a full-up system. Next slide, please. So again, the framework that we developed, it was collaboratively developed between AFRL. I want to also acknowledge my collaborators on the NATO report from NASA Langley's Research Center, MBDA in UK, as well as Dr. Bill Overkamp. He is a internationally recognized validation and verification subject matter expert, going back to his work at Sandia National Labs. So we really, are interested here in identifying and prioritizing what we call capability gaps. We want to identify high priority, maybe ground test and flight test experiments that we connect to a MBSE representation of what our system is going to look like. So I'm going to show you here in a little bit what our output of our project, coming out of our projects were, and then talk a little bit about what the path forward is for, how we might, improve the representation of that using a lot more of the ontology capabilities that you would see from OpenCaesar. And that's really what just by listening to all the great presentations today, I realized that this was a good decision to engage with this group. I really think this is the future of where a lot of the things that the AFRL is going to be looking at going in the future is going to look at. So we want to really identify a model validation hierarchy as a new type of digital artifact and get our leadership and our stakeholders to recognize that that is a strategic resource investment. And I'll talk a little bit more about what that means in the next few slides. So next slide, please. So what you're seeing here, I'm going to draw your attention to the what I call a sunburst diagram. It's just something that comes out of our go-to tool, which unfortunately about 4 years ago when our project started, Excel was what we had, and we stuck with it through all the way to the bitter end. But what you're seeing here is a system level decomposition from the top level, which represents the system's architecture. But if you build up from the bottom, actually what you have is a physics-based taxonomy. So we're starting at the very low level of what we would call a unit level experiment. So this could be something that is representative of the interactions between the propulsion system on an airplane, and as well as its integration with the airframe. So similar to the PAI modeling that you might get, you have very low-level complex flows that you can imagine that might exist with an airframe or something like a missile system. So as you go up that the tree from the bottom of the tier all the way up through what does the connectivity look like with the systems architecture, and if you can you envision what that would look like, it's going to be something I think would be very beneficial to a more of a semantic ontology approach. So reduction of that complexity through decomposition for an arbitrary number of tiers is what we want to try to look at. And it's really a perspective shift in that this transition tier allows us to connect our systems architecture to the top of the modeling and simulation activities at the bottom. Go ahead and go next slide, please. So this is a representation inside of Magic Draw that shows how our ontology elements are laid out. So we're looking to replace the sunburst diagram that I showed you on the previous slide, and we're trying to figure out what the best way is to represent that inside of Magic Draw and leveraging SysML diagrams. So this is what this representation shows. And this is just using the standard packages and the block definition diagrams available within SysML. So this the layout that you see is a preliminary representation. When we go to explain the value of the concept to our stakeholders who might provide us with funding to apply this to a real system, this is kind of the walkthrough that we give them to show the relationships and the behaviors that we would expect out of the interrelating systems. Because surprise and surprise, it turns out where we see a lot of vehicle failures is where we have physics-based fundamental interactions between disciplines. And they're earlier on in our systems engineering process where we can identify those potential mishaps. That really allows us to not only get that systems engineering assessment performed early and earlier in the design phase, but it allows us to discover potential defects in the system before we go and decide to do a more expensive investment to actually go to flight test that concept. Next slide, please. So again, we're talking about ontologies, the relationships between the elements in the system representation become very important, and being able to track that through something like SysML is what we tried to start with. But what we've learned just over the last year, and I lost my software engineer, Mr. Harry Byers, over the summer break. So if you're a software engineer and you're looking for a job, give me a call. We have some additional work here to do, but we're looking at now how to extend maybe beyond SysML to something like the OML capabilities that we've seen here today. Next slide, please. So these slides will be available. I won't go too much into detail here, but our actual application of our methodology, we have a few peer-reviewed publications that are in process. Majid, I will definitely share those with you. We just got those publications accepted. It shows the actual application of our methodology to a missile system example. So it shows the full elucidation of what the SysML diagrams look like, all the way from our systems level tier down to the physics-based modeling. So these are just representations of some of the models that we capture in the ontology. Very, very important is the propulsion and the airframe model, and that's where we've actually devoted most of the focus. Next slide, please. So this diagram, again, it's a block definition diagram. It really shows the focus on the aerodynamics and the structural models, but it shows you more of some of the unit interactions that you get that you may choose to focus on for a particular type of experiment. Maybe this is something that you could conduct these types of experiments inside of a wind tunnel, and then we want to use these models to reduce risk. Because as we build up what this model-based representation looks like of the system, we then progress up the tree from unit interactions up to complex flows, and they all influence the top-level aerodynamic model. But this is what the model tree looks like for that type of ontology. Go ahead and go to the next slide. So this is really where the future work is, and I didn't put it explicitly on here, but how to implement what we've already done within inside of something like OpenCaesar. That's really what I want to spend the next several months looking at internally for our research team. We also want to expand the profile development, establishing a style guide for how you might implement a model validation hierarchy for a real system. And then the actual application of the process, which is described in the publications that I will send to JPL to make that available. It's the implementation of a help table, and it's really a prioritization of the hierarchy elements, which allows us to focus where our program resources would go for the places where we don't have a lot of confidence in our predictive modeling and simulation. And really, it's identifying those capability gaps and high priority activities with our limited resources is how we want to leverage these ontologies. So I think that's the last slide. Go ahead, one more. And I'll stop there and let you go on to the next speaker. But thank you very much for the opportunity. Please reach out if you'd like to talk a little bit more about this. Over.